Today we're looking at properties of rational exponents. So this is our exponents that are fractions. All the same rules that we looked at before still apply. So the power of powers, the product of powers, all those different things. But now you have fraction exponents, so there's a few different things you're going to have to keep in mind. So for instance, if we start with our first one, when we have both of them have a base. So if we have 5 to the 1/4 times 5 to the 3 over 2. We know from before that we're going to need to add these exponents. However, in order to add fractions, you have to have a common denominator. So if we have a 1/4 and a 3/2, then we're going to need to make both of these into have a denominator of 4. So this would be 5 to the 1/4 plus, times 5. 3/2 to be 4s would be 6/4 because we multiply top and bottom by 2. So then when we add our exponents together, we get 5 to the 7/4 power. And that would be our answer. So when adding, you need to make a common denominator in order to add those fractions together. Then you just add the tops. If we had 3 to the 5 over 2 squared, here's where we want to multiply our exponents. So this was add exponents. This is going to be multiply exponents. So if we think about multiplying 5 over 2 times 2 over 1, so we'll have 3 to the 5 over 2 times 2 over 1. There's a couple ways you can look at this. You can multiply straight across and get 10 over 2. You can also look and say that the top and bottom both have a factor of 2, so the top we're multiplying by 2, on the bottom we're dividing by 2, so those would cancel each other out, which would just give us the 5 over 1. However you go about doing it, you end up with the same thing. So if we multiply the tops, we get 10 over 2, which then reduces to 5. Again, if we were to cancel out these 2's, then we would just be left with 5 over 1, which is exactly what we got there. And you can compute from there. Next, if we have 6 to the 1/2 times 4 to the 1/3, all of that squared. Here my exponent is on the outside, so we're going to be distributing that exponent, and we're going to be multiplying it to the exponents that are already in there. Notice that inside my parentheses, I have a 6 to the 1/2 and a 4 to 1/3. I cannot combine these at all because they have different bases. So they're going to stay separate because they have different bases. So if we look at this, we've got 6 to the 1/2 times 2. Well, if you think about 1/2 times 2, that just gives you a power of 1, times 4, 1/3 times 2 would be 2/3. Again, if you multiply the tops, if you want to make this a 2 over 1, if that helps you to multiply your fractions, then that's perfectly fine. So we've got 6 to the 1st times 4 to the 2/3, and that would just be your answer. You'd probably rewrite it as 6 times 4 to the 2/3 power. There is nothing else you can do that does not equal 24 because this 4 has an exponent, this 6 does not, so they cannot multiply. Very important here, this is your final answer, to leave it as 6 times 4 to the 2/3 because they do not have the same exponent and they do not have the same base. Next, if we look at, let's try another one of those, where we have 4 to the 5th times 3 to the 5th to the negative 1/5 power. On this problem, we have a couple different options of what we can do. One of the things that you'll notice is that both my 4 to the 5th and 3 to the 5th have the same exponent. Okay, so it's very important to notice here they have the exact same exponent. Because they have the same exponent, I can multiply their bases and leave the exponent the same. So because they have the same exponent, I can write this as 12 to the 5th power to the negative 1/5 power. Because they have the same exponent. The only reason I can multiply their bases is because they had the same exponent. And then we would multiply their exponents to simplify it even further. So we'd have 12, 5 times negative 1/5 would be negative 1, which we would then write as 1/12. The other way you can do this is you can distribute that negative 1/5 just like we had done earlier. So we would have 4 to the negative 1 times 3 to the negative 1, which equals 1/4 times 1/3. which since we're left with 1/4 times 1/3, we can multiply that. There's no exponents left over, so now they can multiply. So we end up with 1/12, which is the exact same answer. So however you want to go about working it, just know that if you have the same exponent, you can multiply their bases. The next one I want to look at is 36 to the negative 1/2 power. So we know that we can rewrite this as 1 over 36 to the 1/2 power. We also know that we can rewrite the 1/2 power as 1 over the square root of 36, because my exponent is a 1, my index would be a 2, which is a square root. We know that the square root of 36 is 6, so we're going to write it as 1/6. You have to simplify there if possible. On these other ones we've done, here we had 4 to the 2/3. We don't know what the cube root of 4 is, so that's why we left it there. Here we don't know what the the 4th root of 5 is, so we left it there. 3 to the 5th you could compute out. That's one of those. It's not in the realm of the ones I need you to memorize. And so I'm just going to leave your answer like that. Okay, so coming back down here, and just get used to recognizing that the 1/2 power is a square root. Next one we're going to look at is 5 over 5 to the 1/3 power. So here we've got division, which is when we subtract our exponents. It's much more helpful if you write the 1 up here for your power of the 5. So this is going to be equal to 5 to the 1 minus the 1/3 power, because we subtract our exponents. This one has a 1, this one has a 1/3. Write that 1, otherwise this problem gets very confusing. So if we do 1 minus 1/3, you can either just think logically about it, or if you need to change your 1 to have a common denominator, that would be a 3 over 3 exponent. So 3/3 minus 1/3 would be 5 to the 2/3. Again, we don't know the cube root of 5, so we're going to leave our answer like that. Finally, the last one I want to look at is 42 to the 1/3 power over 6 to the 1/3 power, all of that raised to the power of 2. Again, if you notice, 42 and 6 both have the exact same exponent. You want to look for that to see that they have the exact same exponent, because that's going to make your problem easier to simplify. So we know that 42 to the 1/3 power and 6 to the 1/3 power, same exponent, so we can actually do that 42 divided by 6. So that leaves us with 7 to the 1/3 power, because 42 divided by 6 is 7, and they both still have that 1/3 power, and then we're going to take that to the power of 2. Here we multiply our exponents, so we end up with 7 to the 2/3 power. Again, the alternate way of solving this problem is to distribute that 2 first, so we'd have 42 to the 1/3 power to the 2/3 power. If we multiply that 2 to both my exponents, over 6 to the 2/3 power. And then again, you have the same exponent, so if you divide the 42 divided by 6, you would end up with 7. And the reason why you can do that when they have the same exponent is just like we distributed the squared to top and bottom, we're going to factor out this 2/3. So we'll end up with 42 over 6 to the 2/3 power, because that would distribute back out and give us what we had. We know that 42 over 6 is 7 to the 2/3. So we end up with the exact same answer. The reason why we can do the division or the multiplication if they have the same exponent is because you can factor it out just like we did here. You can factor it out.